Hi guys, and welcome to the video on area and perimeter of compound shapes. So, we're going to be learning to compute the area of shapes that are made by combining smaller ones. This is because area of real-world shapes is usually calculated by using the compound shape idea, and you'll know you're successful when you can break a shape down into smaller parts, find their area, and then combine. So, let's just get started with the area and perimeter of a circle. We are going to need these formulas for this section. The area and the perimeter of a circle are known as, well, the area and the circumference for the perimeter. To find the area of a circle, you need to know the radius. And remember that the radius, I'm going to draw one here. The radius is from the center of the circle to the edge. This is the radius. If you were to continue this all the way across, that entire length here would be the diameter. And so it's just worth noting that the diameter is twice the radius. To find the area of a circle, you take r squared and multiply it by pi. To calculate the circumference of a circumference of a circle, you take the diameter and multiply it by pi. Exact versus approximate. So starting with this section, I'm going to ask for exact versus approximate because with circles, you can't really be exact unless your answer has pi in it. And so I'll give you an example. 5 pi would be the approximate, or would be the exact answer for area of a circle. Whereas approximate area of a circle would be 15.71. 12 pi would be the exact area of a circle, whereas the approximate would be 37.7. And then 8 pi over 3 could be an exact distance, like a radius or something. And that would be approximately 8.38. So if I ask you for an exact answer, your answer should have pi in it. It's basically pre-calculation. So this would be like pre-calculator. And this would be post-calculator if you typed in the pi into the calculator. So hopefully that's clear. Alright, so to actually calculate the area of a compound shape, just split the shape into smaller, easier to calculate shapes. Then in succession, add the areas together. For this here, I could do base times height. And then I can go ahead and add in base times height over 2. And I can add those sums together to get the total area. So let's just get started. Find the area and the perimeter of the shape below. So I'm going to just start off by cutting the shape into fictional parts here. So immediately I have a rectangle and I have two triangles. So then what I am going to do is draw in heights for these triangles, altitudes for these triangles. The triangle on the top, this triangle with it, which is all this segment in here, has a base of 1, 2, 3, 4, 5, 6, 7, 8. So its area would be equal to a base of 8 times it is too high over 2. So the area of that portion would be 8. So 8 units squared. So that's all of this, okay? I mean this included too when I say all of it. So now if I were to go and then calculate this area in here, that area would be base times height. And base times height here would be, I know that there is a base of 8 and a height of 4. Because I can count the 8 squares again and a height of 4. So that the area is 32 units squared. And then I'm going to calculate for this triangle with this height. The area is equal to base times height over 2. So the area would be a base of 8, have a height of 3 divided by 2. It would be 24 over 2, or an area of 12 units squared. So to calculate the shape's total area, I would simply take the 8, the 32, and the 12 and add them together. So 8 plus 32 plus 12 equals 52 units squared. Okay, well, unfortunately, the area here happens to be the easiest thing to calculate. Now what we have to do is calculate the perimeters. So I have a 4 here, I have a 4 here, but to calculate the actual shape for the rest of the sides for the perimeters, I'm going to need to use Pythagorean theorem. And the reason that I need to do that is because whenever we're moving diagonally on the coordinate grid, we have to use Pythagorean theorem. Although it should be nice and simple. I have a side of 3 here, a side of 6, a side of 2, a side of 3, a side of 5, and a side of 2. So I can go ahead and just quick do those calculations. To get this side here, it will be 2 squared plus 3 squared. And 2 squared is 4, 3 squared is 9. So we're talking about 13. And then taking the square root of that leaves you with about 3.6. For this one, I did 2 squared plus 3 squared equals c squared. And it comes out to about 3.6. I have another 2 and 3 here, which means this length here, when added together, will be 3.6 as well, because you can see the calculations down below. I have a side of 2 and a side of 5. So 2 squared is 4 plus 5 squared is 25 and is 29. So you take the square root of that, and this up top would be about 5.4. So I did 2 squared plus 5 squared equals c squared here, and then that's about 5.4. C. Okay, and then I just need the one down here for the last of my perimeter, and that has sides of 3 and 6. So 3 squared is 9 plus 36, and that's 45 because 6 squared is 45. Take the square, or 6 squared is 36 plus 9 is 45. Take the square root of that. C down here was equal to about 6.7. And that's doing 3 squared plus 6 squared equals c squared for this over here. So now I can just add up all of those sides. So I've got the 4, the 3.6, the 5.4, another 4, 6.7, and 3.6. So let's just go ahead and add them all up. So 3.6 plus 3.6 again, plus 4, plus 5.4, plus another 4, plus 6.7. So I added all of them up together. So the perimeter was equal to 3.6 plus 4 plus 3.6 plus 5.4 plus 4 plus 6.7. And when all that is said and done, the perimeter was equal to a grand old 27.3 units. Okay, moving on. Find the area and the perimeter of the shape below. Okay, so I'm missing a couple parts for the perimeter, but I think that the area should be no problem. So I'm gonna just do this really quick. And this only matters because 50 centimeters, so this I can already tell is a rectangle. And this whole bottom is 180, meaning up to here, this part is 110 centimeters. So using some logic, this right here is 180, take away 110 already used, or 70 centimeters. Not 70 degrees, excuse me, 70 centimeters. If I apply the same logic, 50 centimeters is used out of 140, 90 centimeters here. So I have all of the missing information that I need, except this segment right here. That's the one segment that I don't know about right now. So what I am going to do, though, is do the Pythagorean theorem of 70 squared plus 90 squared equals, we'll call it c squared. So 70 times 70 gives me 4,900. 90 squared is 8,100 for a total of 13,000. And then we're going to go ahead and take the square root. So I got 13,000 equals c squared. Take the square root. C is equal to 114.0 when rounded. So C is equal to 114.0. I'm leaving the 0.0 to signify that it's been rounded to 0.0, so it's not exactly 0.0. Now I'm going to just go ahead and add them all up. I've got 180. So to calculate the perimeter, I've got the 180 on the bottom. Plus I got the side that I calculated, 114. I have a 50. I have a 110. And I have a 140. So I'm going to add all those up. So 180 plus 114 plus 50 plus 110 plus 140 gives me a perimeter here of 594 centimeters. So then to actually calculate the area, I just need to do the area of the rectangle and the area of the triangle. So the area of the rectangle, you've got a height of 140 and a base of 110. So the area is going to be equal to 140 times 110 divided, and that's it. So the area of the rectangle is 15,400 centimeters squared. But we need to add that to the area of this triangle over here, which is 70 times 90 divided by 2. So 70 times 90 divided by 2 gives me an area of 33,150. So we're going to add that in here. And the total of 15,400 plus 3,150 is 18,550 centimeters squared. Okay, moving on. So find the area and the perimeter of the shape to the left. Finally, a circle problem. Okay, so the distance that they give me, okay, 8 represents the diameter here. Okay, it is not the radius. So if 8 is the diameter, then 4 is the radius. The other thing that I know is to calculate this leftover side here, I'm going to need to use 8 and 12 in Pythagorean theorem. So I'm just going to knock that out of the park right away. 8 squared plus 12 squared is equal to c squared. And we'll call this c right here. So 8. So you get 64 plus 144 equals c squared. You get 208 equals c squared. Taking the square root of both sides, c is equal to, and it's going to be a decimal, 14.4 when we round it. Okay, so 14.4 meters equals c. And then what we're going to do is we are going to calculate the area first of the triangle. So the area of the triangle would be the base times the height. divided by 2. So the area would be 12 times 8 divided by 2. 12 times 8 is 96 divided by 2. The area is 48 meters squared for the triangle. Okay, I still have to calculate the area of the circle. So to calculate the area of the circle, I'm going to take the radius. I need this one for the circle, and you do the radius squared times pi, r squared times pi. That's where it's coming from. So I get a is equal to 16 pi. So if I actually, and that would be meters squared. If I'm actually going to add these together, my exact answer, so I'm going to do the exact answer here, and then I'll have an approximate as well. The exact answer here is actually going to be written as 48 plus 16 pi meters. That is the exact answer, because you can't add 48 and 16 pi. Pi is like a variable that 48 doesn't have. If you wanted to write the approximate answer, so I'll write APP for approximate, what you would do is multiply 16 times pi. And multiplying 16 times pi will give you a decimal that you can approximate. And that is, you can then add that approximate decimal, to the 48. Sorry, I'm having a brain fart there, guys. So if you add those together, so if you do 16 pi, you get 50.265, and then you add 48 to it, and you get 98.26 meters, approximately. Now, perimeter-wise, I need to add all of these together, and to calculate the perimeter here, okay, the circumference of the circle would be the diameter 8 times pi. So the circumference is 8 pi, but we only have half of a circle here. This is only half of a circle, so we need to do half of the circumference. So really what we're looking at as half of the circumference, c over 2, is equal to 4 pi. So this distance here on the shape is actually 4 pi. So we're going to need to add 14.4 plus 12 plus 4 pi, but we can't really add it together. So exactly the perimeter, if we did the perimeter exactly, it's 26.4 plus 4 pi meters. Oh, this should be meters squared up here. And approximately, that's approximately, you have to take and multiply pi by 4, and then add 26.4 to that, and you get 38.96 meters. And 2 decimal places because it's approximate. So I realize this video is getting on in length, guys, so I'm going to go ahead and skip this next one and just move on to the last one here. Remember that you could use the idea of compound figures here in order to split these up. So I've got a 22-foot driveway, a 10-foot driveway, and a 10-foot driveway. So this needs to be 10 here, and this needs to be 10 feet here. So remember that in a problem like this where it says the cost of pouring concrete is rated at $15 per square foot, I need a driveway poured. My driveway is shaped like this. How much will it cost to have the driveway poured? I need to know the total area that's going to be covered. That's what per square foot gives away. This is going to be an area problem. So if I calculate the inside the square here, I get 100 feet squared. If I calculate inside this rectangle, base times height would be 220 feet squared. And then calculating inside this triangle, 10 feet by 10 feet, but then it's half of it, it would be 50 feet squared. So I broke it up into triangle, square, and rectangle. So now I add the 220 plus the 50 plus the 100, and that gives me 370 square feet that have to be covered, multiplied by $15 per square foot. So I'm going to take 370 and I'm going to multiply that by 15, and I get $5,550, which seems pretty reasonable for the size of the driveway. So that's it, guys. In summary, remember that compound figures can be broken down into smaller, easier to calculate parts and then added together for ease of completion. Sometimes these compound shapes involve circles. Remember the formula for area of a circle and circumference. And then, as always, make sure you use the Pythagorean theorem where necessary to find missing sides. That's it for today's video. Thanks for watching, guys. I'll see you in the next one.